Good morning, students, and once again, welcome you all in our E class of learning. Let's continue with the same topic which we were discussing yesterday. Okay, so we have completed problems related to molecular formula, empirical formula. We'll jump further and we'll talk about the chemical reactions and stoichiometric calculations. What do you mean by chemical reactions and stoichiometric calculations? Okay. Now, calculations which are based on balanced chemical equation are called as stoichiometric calculations. Okay. But what is a balanced chemical equation? Balanced chemical equation is a symbolic representation of a chemical reaction. A one mark question can be asked on this ki what is a balanced chemical equation? It is the symbolic representation of a chemical reaction. And like what are stoichiometric calculations? If a question is like that, you have to talk about the calculations which are based on balanced chemical equation are called as stoichiometric calculations. Okay. Now this equation supplies you certain information which is very important for solving the problems based on chemical equations. Okay. Now, what does this indicates? It gives you number of moles of the reactants involved in a chemical reaction and number of moles of the product form. कितने मोल्स रिएक्टेंट्स के यूज हुए हैं और कितने मोल्स प्रोडक्ट के फॉर्म हुए हैं, आपको यहाँ से ये आइडिया मिलता है केमिकल इक्वेशन से. नेक्स्ट इज it also indicates the relative masses of reactants which are taking part in the reaction. कितने masses reactants के reaction में involve हो रहे हैं और कितने products form हो रहे हैं during a chemical reaction. Okay. और अगर gases reactants are involved, it indicates the relationship between the volumes of the gases, reactants and products at standard temperature and pressure. In short, we write it as STP. Okay. Now next, what like I told you stoichiometric calculations, but what is stoichiometry? It is the study of quantitative relationship between the amount of reactants and the products. आपने कोई chemical reaction देखा है? What quantity of reactants are involved and what quantity of products are formed? It give you actually the quantitative relationship between these. Okay. Now let's start with the stoichiometric problems. But before I could start the problems, you have to follow certain general problems which are based. There are different types. Okay, as it is, the problems are based on mass-mass relationship. Like you can talk about the molar mass. They are based on mass-volume relationship और दे आर बेस्ड ऑन वॉल्यूम वॉल्यूम रिलेशनशिप. आप जो भी प्रॉब्लम सॉल्व करोगे दे मस्ट बी बेस्ड एनी ऑन एनी वन ऑफ दिस टाइप्स. ओके. So whenever we are solving the problem, you'll get an idea about all this. There are certain steps for solving the problems. Let's see what are the different steps which we have to follow while solving the problems. The first step जो है आपको एक chemical reaction बताया है, but you have to write the balanced chemical equation representing that chemical reaction. Please remember, when I talk about any chemical reaction, you have to write the balanced chemical equation for that particular chemical reaction. Okay, this is the step one for solving any problem. The next is write down the number of moles and relative masses or volumes. अभी आपको जो example दिया होगा, depending upon that particular problem, sorry, you are going to write what is expected, number of moles or relative masses or volumes, like depending upon like whether it is a mass relationship, mass volume relationship or a volume relationship, you have to write about accordingly of the reactants and the products below the respective formula. Now, first of all, you are going to write the chemical reaction, and below that chemical reaction, you are going to write exactly below that particular reactant or the product, its number of moles or masses or volumes are below the reactant and the products respectively. Okay, whichever is there. Relative masses or the volumes should be calculated from the respective formula mass. Now, as it is, you are accordingly going to calculate. As it is, the moment we solve the problem, you'll get an idea about this, how you're going to calculate all this. Calculated from the respective formula mass, referring to the conditions of standard temperature and pressure. And next is you have to follow a unitary method to calculate the unknown factors as required by the problem. Okay, so these are the 4 steps which we are going to follow to solve the problems related to this. Okay, now let's take one problem. A very simple problem is given to you. Calculate the mass of carbon dioxide and water which is formed on complete combustion of 24 grams of methane gas. Now, आपको यहाँ पर methane, you have, from this you can make out methane is a reactant. Methane undergoes combustion or methane is burnt. Combustion means burn. Now, when methane is burnt, you have the release of carbon dioxide and water. When it is completely burnt, it is forming carbon dioxide and water vapor, actually we have to say. तो आपको सबसे पहले यहाँ पर केमिकल रिएक्शन, आई वांट द केमिकल रिएक्शन ऑफ मीथेन्स रिएक्शन with oxygen. It is completely burned and you have the formation of carbon dioxide and water vapor. See, when I talk about methane, only one carbon is there, so one molecule of carbon dioxide is formed, and since 4 hydrogens are there, 2 water molecules are formed, so accordingly you can balance the chemical equation. Unless and until you write the balanced chemical equation, you are not able to solve this problem further. So please see this. When I talk about a balanced chemical equation, the number of atoms of different elements which are present on the reactant side is equal to the number of atoms of the that particular elements on the product side. So please remember this part. Okay, now, under this balanced chemical reaction, under the product side and under the reactant side, accordingly, you are going to specify, as this is the problem of a mass relationship. See, everything is given in grams, so it is a mass relationship. Okay. Now, in case of methane, if you see, एटॉमिक मासेस भी आपको प्रोवाइड किए गए हैं, सो डोंट बी पैनिक, बिकॉज एज आई हैव ऑलरेडी टोल्ड यू कि एटॉमिक मासेस जब भी कोई प्रॉब्लम पूछा जाता है आपको एटॉमिक मासेस प्रोवाइड किए जाते हैं विच आर रिक्वायर्ड फॉर सॉल्विंग दैट पर्टिकुलर प्रॉब्लम. ओके, नाउ यू नो द एटॉमिक मास ऑफ कार्बन इज 12. So in case of methane, the molar mass of methane 12 plus 4, it becomes 16. Okay, because hydrogen ka atomic mass 1 hai. Similarly, when I talk about 2 times oxygen molecule, that is 2O2, that is 2 multiplied by 16 into 2, that is 64 grams. Similarly, come under the product side and just see where I am pointing the pointer. Please uh, watch on the slide where I'm pointing. Now, in case of carbon dioxide, molar mass is 12 plus 16 into 2, that is 44. Okay. Now, in case of water, similarly, 2 moles of water, and accordingly, the atomic masses for hydrogen and oxygen are given to you. Here, like I have written directly 2 because it is 2 into 1 is 2 only. So, total mass of the water vapors which are liberated is 36 grams. Okay. Now, from this, like the balanced chemical equation जब तक आपके पास नहीं होगा आप ये नीचे वाले values नहीं बता सकते हो. The moment you are not able to tell me the right values, the moment you won't be able to solve the problem also. Okay, so the first criteria is the balanced equation should be correct. Okay, so the next one is like what I want you to remember over here. 16 grams of methane when it is burnt, I get 44 grams of carbon dioxide. Please see on the screen. Okay, so this is what is the relationship which I am going to follow. When I burn 16 grams of methane, I get 44 grams of carbon dioxide. Similarly, when I burn 24 grams of like this methane, how much carbon dioxide is liberated? So that's what I want to specify. Next, one more thing you have to remember, ki when I burn 16 grams of methane, 36 grams of water vapor are liberated. So when 24 grams of methane is burned, how much water vapor are liberated? So you have to specify accordingly. So let's jump further and see, when 16 grams of methane on complete combustion, I get 44 grams of carbon dioxide. Therefore, when I burn 24 grams of methane, so just you have to say ki like 24 multiplied by 44 divided by 16 is equal to 66 grams of carbon dioxide. Now, when I'm burning 24 grams of methane, I get 66 grams of carbon dioxide which is liberated. Okay. Similarly, when 16 grams of methane is burnt or it undergoes combustion, 36 grams of water vapor is liberated. Therefore, when 24 grams of methane is undergoes combustion, complete combustion I'm talking about here, the water vapors which are liberated are like 24 into 36, sorry, 24 into 36 divided by 16. So my answer is 54 grams. Okay, so this is what is expected from you when a 2 marks question can be asked on this. And I just want you to please make a habit of writing the balanced chemical equation. Unless and until you write a balanced chemical equation, you won't be able to solve this problem. Okay, further solving the problem is very easy, but writing the balanced chemical equation is very important. Okay, now let's take one more example, or let's solve one more problem. How much of calcium oxide will be produced by decomposition of 5 grams of calcium carbonate? Now, from the problem itself, like in the problem itself, it is written कि calcium carbonate undergoes decomposition. Okay, and you have the formation of calcium oxide. So, first of all, I want a balanced chemical equation. So, on the reactant part, I'll write calcium carbonate. On the product part, I'll write calcium oxide. See on the screen where I'm pointing the pointer. So I just want the balanced chemical equation. That is what is my first point over here. Calcium carbonate, जब आप strongly heat करते हो तो it gets decomposed into calcium oxide and carbon dioxide gas is released. Okay, so see, it is a balanced chemical equation. As I told you, how you can determine whether this is balanced. Number of atoms of different elements on reactant side is equal to number of atoms of different elements on the product side. This is what you have to remember. Now next is calcium का atomic mass. आपको second step, पहला step ये है कि आपको balanced chemical equation लिखना है जो आपने लिख दिया है. Now the second step is I just want to write the molar mass. Reactant case में आपके पास calcium carbonate है. Atomic mass of calcium is 40, carbon is 12, oxygen is 16. This will be given to you during exam. Okay, so I am just calculating the molar mass of calcium carbonate. Is it clear? Now this total is 100. You can even write 100 grams. Okay, when I solve the problem, I say कि I'm taking 100 grams of reactant, and when 100 gram of reactants is decomposed, what do you get? Product मुझे 100% ही मिलेगा, लेकिन different है यहाँ पर दो products है. Okay, so I get calcium oxide, that is 40 plus 16, that is 56 grams or 56 parts also you can write, and carbon dioxide gas is released, which is again the molar mass of this is 44 total, that is 12 plus 2 multiplied by 16, which is 44 grams. Okay, so this particular is for carbon dioxide, this is for calcium oxide, and this is your calcium carbonate. Now, how much calcium oxide will be produced by decomposition of 5 grams. Now see here, where now in this case 100 grams of calcium carbonate decomposes to give me 56 grams of calcium oxide. तो फिर 5 grams of calcium carbonate अगर decompose होता है तो what do I get? Okay, so let's jump to the next slide and see. 100 grams of calcium carbonate produces 56 grams of calcium oxide. Therefore, 5 grams of calcium carbonate will produce, that is 5 into 56. I just cross multiply over here. 5 into 56 divided by 100 is equal to 2.8 grams of, this is calcium oxide. Please make a correction. This is a printing mistake even in your textbook also. So please correct this. This is calcium oxide. Okay. I am decomposing calcium carbonate and I get the product that is calcium oxide. So please यहाँ पर CaO करो. तो जब आप 5 grams of calcium carbonate को decompose करते हो तो आपको 2.8 grams of calcium oxide मिलता है. Okay, now from this you can make out कि unless and until you write a balanced chemical equation, you won't be able to solve this problem. Okay. Now let's jump to the other problem. One more problem I want to take it for as it is for today. How many liters of oxygen at standard temperature pressure are required to burn completely 2.2 grams of propane? Now, again, this problem is of the same time where we were talking about the combustion of methane. Here I'm talking about the combustion of propane. Okay. So, how many liters of oxygen is required when I burn 2.2 grams of propane? So, I just need a balanced chemical. My first step is I want a balanced chemical equation, that is, my reactant is propane, and what do I get here? Like from the last problem, you can make out that I get carbon dioxide and water vapors. Okay. So first of all, just write down the balanced chemical equation in your notebook. C3H8 is the molecular formula for propane. When this propane is burnt, I get carbon dioxide and water. You all know this. Carbon dioxide and water is released when the propane is burnt. Now, since 3 carbon are there, so 3 molecules of carbon dioxide and 8 hydrogens are there. So I'll just write 4 water molecules are liberated. So depending upon the number of oxygens which are consumed over here, you can write the reactant oxygen molecules by counting the numbers. Okay, this is the way like you can even write the chemical balanced chemical equation nicely over here. Okay. Now my next step is I want to write the masses. Since this is an example, if you can see on the screen, in the problem itself it is written कि you're talking about the liters of oxygen, means I'm talking about the volume. So this is a problem of a mass volume or a volume mass relationship. Okay. So let's calculate the molecular mass of propane, that is 3 multiplied by 12 plus 8 into 1, which is 44 grams. Similarly, here we were talking about the liters of oxygen. Okay, that is how much liters of oxygen is required. Now, from the balanced equation, I can calculate. Now, I just want to clear one more step over here before I can proceed. Just see here, when 1 mole of an ideal gas, 1 mole of an ideal gas occupies 22.4 liters of volume. So you have to remember this. You have to learn the statement कि 1 mole of an ideal gas occupies 22.4 liters of volume. And in this reaction, if you see, O2 is 1 multiplied by 5. So these are the 5 moles of the oxygen gas. Okay. So for 1 mole, you require 22.4 liters. And for 5 moles, as it is multiplied by 5, so for 5 moles, I required 112 liters of oxygen. Is it clear? It will be occupying 112 liters of the volume, I mean to say. Okay, so this is, you have to learn this. There is no other way out. Does Just I'll go back again and just see on the screen where I've written 44 grams of propane requires 112 liters of oxygen. See the relationship. When 44 grams require 112 liters, so 2.2 grams of propane require how much liters like of oxygen gas. Okay, so I'll just cross multiply this. That is 2.2 into 112 divided by 44. We can jump and see from the next slide. 44 grams of propane requires 112 liters of oxygen for complete combustion. Therefore, 2.2 grams of propane require how much? Okay, so 112 multiplied by 2.2 divided by 44, which is equal to 5.6 liters of oxygen. Okay, so for complete combustion of 2.2 grams of propane, I require 5.6 liters of oxygen gas at standard temperature and pressure for complete combustion. Is it clear? Now, today, as it is, I just want to give you these two problems as an assignment. Please write down these problems and you can solve it in your notebooks. Click the pic and send me on my WhatsApp number, or those who are in the group. I am just specifying those who are already there in the group. WhatsApp groups are there for 11C, girls and boys separately. Those who are in the group, please send in the group and write down your name below that. And the other students which are in the D division can please send me on my personal number. Plus, they have to write their name below that because I don't understand who is sending me this answer. And literally, I would like to share that there are so many students who are solving the problems and sending me the pics. I'm really very happy. So keep it up. Just write down the problem. What weight of calcium oxide will be formed on heating 19.3 grams of calcium carbonate? This example is very much similar to what we have taken earlier, okay? And the answer is 10.8. This is just a hint for you. You have to write the balanced chemical equation. Accordingly, write down the masses below that and solve. And the next one is second problem. The hourly energy requirements of an astronaut can be satisfied by the energy released when 34 grams of sucrose are burnt in his body, full stop. How many grams of oxygen would be needed to be carried in space capsule to meet his requirements for the day? Even I have given you the hint for this answer also. I just want you to solve this problem. If at all you are not able to write, it is given in lesson number 2 backside exercise. You can see these two examples are given. Solve these examples and let me know on the WhatsApp, and I'll be continuing my lectures on next Friday and Saturday. Till then, thank you and bye. Take care of yourself.